Okay, good morning, students. You are all welcome to this morning class. This morning we'll be looking at Identities 1, 2, 2. We'll be looking at trigonometry, geometry, identities. Amen. We'll be looking at trigonometry identities. We are going to prove identities. Is that clear? This morning, that is what we'll be looking at. Amen. That is what we'll be looking at. Please try and invite others to be part of the class. Is that clear? Invite others to be part of the class. Okay. If we can recall, in our last class, we are looking at, we solved one or two problems, if I'm not mistaken, two of us. So let's recall our right angle triangle. Amen. Let us have our right angle triangle. Here is our arrow, hypotenuse. This is hypotenuse, right? This is y, opposite. This is x, adjacent. This is our right angle triangle. Yeah, two of us. Then we recall SOHCAHTOA. Recall that SOHCAHTOA is very important. Amen. Yeah. So if you agree with me, let's take note of this. Sin theta is equals to what? Opposite all over hypotenuse, which is equals to what? Y all over what? R. Two of us. Then cos theta is equals to adjacent all over hypotenuse. Amen. This is equals to x all over what? R. Two of us. Then our tan theta, tan is equals to opposite all over adjacent, which is equals to opposite is y all over x. Two of us, if we can recall, isn't it? Isn't it? Okay. So take note of that. Do you agree with me? Okay. So if you agree with me, let's proceed further to consider, we want to prove identities. How we have sine square theta plus cos square theta equals to 1. You know, some of you don't know how we got this. Why is this equals to 1? You don't know. So now at this point, what we need to do here is we have to apply Pythagorean theorem. By Pythagorean theorem, amen. By Pythagorean, by Pythagorean theorem, we know that this longest side, the square of this longest side is equals to the sum of the square of the two remaining sides, true or false. That is Pythagorean theorem for you. Amen. So this implies that either x squared plus y squared equals to r squared. This is our Pythagorean theorem. So now what we need to do here is divide through by r squared, divide through by, amen, divide through by r squared. So if we divide through by r squared, it means our x squared all over r squared plus y squared all over r squared equals to r squared all over what? R squared. True or false? Do you agree with me up to this point? Yeah. Okay. So if you agree with me up to this point, look at it. Here is this cancel this one, true or false? So you can see that our x squared all over r squared plus y all over r squared is equals to what? 1. Amen? Okay. So if you can see what I am saying, you don't need a prophet to tell you. If we have in algebra, assuming we have a squared all over b squared, we can rewrite this in this form: a all over b all in brackets squared. True or false? Do you agree with me? So if you agree with me, here will be x all over r all in brackets squared plus y all over r all in brackets squared equals to what? 1. Amen? Okay. So if you agree with me, you don't need the prophet to tell you. Do you agree with me up to this point? Or any question? Any question? Okay. So if you agree with me, where are the rest? It's only 12 people that are here. Civil engineering students. I'm seeing only 12 students. Okay. So if you can see what I'm saying, let's define x all over r. What is x all over r? Let's come here. X all over r here, look at it. Cos theta, true or false? So we write cos theta all in square plus what is y all over r is sin theta. Look at it. Y all over r is sin theta. So sin theta all in square equals to 1. You can now see that this is therefore, we can write this in this form: cos square theta plus sin square theta equals to what? 1. Amen? Yeah. So if you agree with me, this is how you are going to prove this. Then let us also remember that cosec theta is equals to 1 all over sin theta, isn't it? So which is sine inverse. It means sine inverse. It means cosec theta is equals to r all over y. True or false? This is sine inverse. Then sec theta is equals to 1 all over cos theta. This is cos inverse. So sec theta is always equals to what? Is r all over x. Take note of all this. Then tan theta is equals to 1 all over cos theta. This is tan inverse. So this implies that our cot theta is equals to s all over y. Take note. So we'll be using this to prove the identities. Is that clear? So you have to be very smart. Look at the board very well. Copy out what is there. Do you have any question? Is there any question that you want to ask? Okay, so if you can see what I have seen, yeah, it's simple as ABC. It is not difficult. So let's move further to prove the other identity. Amen. Let us move further to prove the other identity. Okay. So this is why we obtain cos squared theta plus sin squared theta equals to 1. Then the other identity we divide through by x. Let us still recall the Pythagoras. We are using Pythagoras theorem. Y squared equals to r squared, right? So if we divide through by x squared, divide through by, amen, divide through by x squared, yeah. So if we divide through by x squared, we are going to have x squared all over x plus y squared all over x, then equals to r squared all over x squared. Then this is the same thing as 1 plus y open all over x open bracket all in square equals to r all over x open bracket all in what? Square. If you understand this one, I don't think that this one will be difficult, be a problem. Okay, so now let's begin to define this y all over x and r all over x. So what is y all over x? Y all over x, y all over x is what? Tan theta, two of us. So here will now be 1 plus tan theta all in what? Square, amen? Equals to, let's define this, r all over x, r all over x, yeah. Look at it here. Sec theta, this is equals to, it means cos inverse, cos theta inverse. Two of us. So r all over x is sec theta, all in square. Hope I'm right. Amen. So look at it. So the final answer will now be 1 plus tan square theta is equals to sec square theta. So whenever you are asked to prove that either sec square, sometimes you will see it in this form or you see it in this form, sec square theta equals to 1 plus tan square theta. Prove that this is equals to this or this is equals to this. This is what you should do. Is that clear? Any question, please? Do you have any question? No question? So we can proceed further, right? Okay. If there is no question, let us proceed further to consider more proofs. Please invite others to be part of the class this morning. It's very important. For the sake of your test, it's very important. Any question? No question? So you mean we can proceed, right? Okay. So let's proceed. Let us proceed. Let's proceed. It means I can clean here. Let me clean here. Okay. We are still using Pythagoras theory. So here, we still recall our x squared plus y squared equals to r squared. So now at this point we are going to divide through by y squared, divide through by, amen, by y squared. So if you agree with me, it means our x squared all over y squared plus y squared all over y squared equals to r squared all over, y squared, amen. So this counts to 1, right? So this is x all over y all in square plus 1 equals to r all over y all in what? Square. So can you see now? So you can now see that let us define x all over y. X all over y is cos theta. Here, look at it here. It means tan inverse. Two of us. Tan inverse. So here will now be cos theta all in square plus 1. Because what is r all over y? R all over y is cosec theta. Which is what? Sin inverse. So here will now be cosec theta all in what? Square. Do you agree with me? So far so good. This is cot square theta plus 1 equals to cosec square theta. So whenever you come across any identity, maybe you are asked to prove that either this is equals to this or this is equals to this. This is what you are going to do. Any question? Let me give you 1 minute to ask question. Any question? Yes or no? No question? Don't have any question? If there is no question, I think we can proceed. We can proceed further. There is no question. Let us proceed further. Let's proceed further. Okay. If there is no question, let us proceed. I want to clean this. Okay. Yeah. Okay, let's consider this question, these identities. Prove that tan x plus cos x equals 1 over cos x. Okay. Another example. Prove that tan x, okay, sin x plus cos x is equals to 1 over cos x. It's simple as ABC. Amen. It is not difficult. Look at the board. Let's look at the board very well. Yeah, let's look at the board very well. As you can see now, what you need to do, proof. Let's write proof. Okay. Our tan x sin x plus cos x is equals to 1 over cos x. Let me use a word. This one is. Okay. Let us note that our tan x is always equals to, tan x is equals to what? Sin x all over what? Cos x. True or false? True or false? If you agree with me. True or false? It's true, right? Okay. So if you agree with me, so instead of tan x, we are going to write sin x all over what? Cos x. So here will be sin x times sin x all over cos x, then plus cos x equals to 1 all over cos x, because what they mean is for us to prove that this left hand side is equals to what? The right hand side. So that is what we are trying to do. So if you can see what I have seen, we take LCM. So note that there is an invisible one here. Amen. Let's take LCM. So if we take LCM, sin x times sin x, we are going to have sin square x, sin square x, then plus cos x times cos x, we have cos square x all over cos x, true or false? Then this is equals to 1 all over cos x. Then note that we just proved this one. Note that our sin square x plus cos square x is equals to what? 1. So instead of this, we write 1 here. So here will be 1 all over what? Cos x, which is equals to, you can now see that the left hand side is what? Equals to the right hand side. So this satisfies the proof. This satisfies the proof. Yeah, so this is how you are going to prove it. Any question, please ask. Do you have any question? Yes or no? No question. Okay, let's proceed further to consider okay. Yeah. Let's move further to some problems. Okay, here we have a question. Show. Another example. Show that cos theta all over 1 plus theta plus 1 plus sine theta all over cos theta equals to 2 all over cos theta. Yeah, we have a very good question facing us now. It's simple as ABC. Very simple. Amen. Okay. Oh, Solomon, you are lost. Solomon is lost. Yeah, it's nothing but the truth. Look at it. We are asked to, Solomon, listen, we are asked to prove tan x and x plus cos x equals 1 all over cos x. What we need to do is note that tan x is equals to sin x all over cos x, two of us. So instead of writing tan x, we replace sin x all over cos x here. Look at it here. But already we have existing sin x here. Look at it here. So instead of tan x, we write sin x all over cos x times this. Sin x plus cos x equals to 1 all over what? This means that we should prove to show that the left hand side is equal to the right hand side. You can now see that the right hand side is 1 all over cos x. So when you see something of this form, let's look at it. If you have a all over b plus b of this form, what will first come into your mind? Is it not to look for the LCM? The LCM of this b and 1, is it not b? B divide b is 1 times a. What we have here plus b to 1, b times b is b squared, two of us. Yeah, so looking at it, this is how it is. So you can now see that cos x divide cos x, 1. So here we have sin x times sin x. It will always give you sin square x plus cos x to 1 cos x times cos x. It's going to give you cos x, cos square x. This is equals to the right hand side, two of us. But note that this is something we just proved. Note that sin square x plus cos square x is always 1. So instead of this, we write 1. Can you see now? You can now see that the left hand side is 1 all over cos x is equals to 1 all over cos x. Do you understand, Solomon? Solomon, do you understand? Solomon, do you understand? Are you following? There's no more here again. Okay, so let's prove this. Let us prove this. Here we have another problem here. It's not difficult. So, prove. Okay. So, how can we prove this? It's the same LCM we are going to take. LCM of 1 plus sin theta and cos theta is the same thing, the left hand side. Let's do it this way. Let's take the LCM, which is 1 plus sin theta, all in brackets, cos theta. So this divide this, will be left with what? Cos theta. Then cos theta times cos theta, we have cos square theta. Now what we have here, plus. This divide this, will be left with what? 1 plus sin theta, then times this. So it means this is what we have, 1 plus sin theta times 1 plus sin theta. Hope I'm right. This is equals to 2 all over cos theta. Amen. So let us multiply these two brackets. Amen. So this is cos square theta plus 1 times 1, 1 times sin theta plus sin theta, then sin theta times 1 plus sin theta, then sin theta times sin theta will have sin square theta equals to 2 all over what? Cos theta. True or false? All over 1 plus sin theta, open brackets, times cos theta. Do you agree with me? Look at the board very well. Do you agree with me? This class is scanty. This morning class very scanty. So if you agree with me, it means that we can add this and this to give us 2 of us. True or false? It's true, right? Okay. So here will be cos square theta. We can bring this one here, sin square theta plus 1 plus sin theta 2 sin theta. Amen. Equals to 2 all over cos theta. Then all over 1 plus sin theta times cos theta. Amen. Yeah, do you agree with me? Do you agree with me? Look at the board very well. Do you agree with me? Okay. So here already look at it. Look at the board. Cos square theta plus sin square theta is 1. True or false? So here will be 1 plus 2 sin theta all over 1 plus sin theta, close bracket, cos theta equals to 2 all over what? Cos theta. True or false? True or false? Look at the board very well. True or false? It's true, right? Moses, you are asking me to come again. I know you are just coming. You are just coming. You are asking me to come again. Oh, Abdullah Kini, how did we get 2 sin theta? Okay, yeah, look at it now. Look at it. If you have a plus a, what do you think you have? Is it not 2a? Look at it. You factor a out. A open by 1 plus 1. This 1 plus 1, 2 times a. Is it not 2a? So if you have sin theta plus sin theta, what do you think you are supposed to have? You are supposed to have 2 sin theta. Take note, please. Is that clear? So now here 1 plus 1. That is why we have, look at the sin theta plus sin theta is 2 sin theta. Note that there is 1 here. But cos square theta plus sin square theta is always 1. So 1 plus 1, 2, right? So 2 plus 2 sin theta all over 1 plus sin theta times cos theta equals to 2 all over cos theta. Do you agree with me? Look at the board, everybody. You agree with me, right? Allah is telling me to take it all over again. Look at it now. Look at it. We are to prove this, that the left hand side, this side, should be the same thing as this, which is 2 all over cos theta. So if we are to prove this, what we need to do, we should consider LCM. If you know how to solve fractions, we should consider LCM. When you, let me clean this part. Let me clean this part. Okay. When you have 4 all over 5 plus, let me say 1 plus sine theta all over cos theta. If you come across expressions for this one, what will first come into your mind? Is it not to look for the LCM? The LCM is, use this to multiply. It means 5 cos theta. So if you use this to divide 5, you are going to left with cos theta. So anything you get, use it to multiply what is there. So it means there will be 4 cos theta. That is what we have been doing there. Look at it. Look at the board. That is what we have been doing there. Look at it. You can now see that 1 plus sine theta cos theta is the LCM. So use this to divide this. We'll be left with cos theta. Cos theta times cos theta is not cos square theta. Plus, use this to divide cos theta. You'll be left with 1 plus sine theta. Use it to multiply 1 plus sine theta. Is it not this bracket you will have, these two brackets? Then equals to the right hand side. Ola, are you following? Do you understand, Ola? Okay, so let's proceed, please. Let's proceed. So here we are going to have, look here, what is common here? 2 is common, we factor it out. So if we factor 2 out, we are going to have 2 open brackets. Here will be what? 1 plus sine theta, close bracket, all over 1 plus sine theta times cos theta, 2 of us, equals to 2 all over what? Cos theta. So you can now see that this and this will go. So we'll be left with 2 all over cos theta equals to 2 all over what? Cos theta. And this satisfies the proof. This satisfies the proof. Yeah. Any question, please? Do you have any question? No question, so we can proceed further to solve more questions. More questions. More questions. Let's proceed further to solve more questions. Proceed further to solve more questions. Prove that cos this equals to, okay. Okay, let's prove that sine square. Another example. Show, amen, that tan square alpha all over tan square alpha plus 1 equals to tan square alpha. Okay. This is another example. Look at the board very well. this is another example that we want to consider again. Okay, so let's prove. Okay, first thing we should consider is note that our tan alpha is equals to sin alpha all over what? Cos alpha. True or false? True or false? It's true, right? So if you agree with me, this implies that anywhere we see tan alpha, we replace it with this. So here, like here, here will be sin alpha all over cos alpha, but tan is in square. Then all over sin alpha all over cos alpha all in square plus 1 equals to sin square alpha. Do you agree with me up to this point? Please look at the board, everybody. You agree with me, right? Okay. Okay. So I can clean here. I can clean this part. So if you agree with me, look at the left hand side. Let's consider the left hand side. It means if we have A all over B all in square, this is the same as A square all over B square. True or false? Okay. So if you agree with me, it means the left hand side will now be sin square alpha all over cos square alpha, then all over sin square alpha cos square alpha plus 1, right, equals to sin square alpha. So here, this is plus. Here we are going to look for the LCM. The LCM of this is cos square alpha. So here will now be sin square alpha all over cos square alpha all over the LCM here, sin square alpha plus cos, I know you ask question, all over cos square alpha, which is equals to sin square alpha. Do you agree with me? Okay. So looking at this, when we have A all over B divides C all over B, this is the same as A all over B times B all over C. This and this will cancel. Two of us want to do something like that here. So if you can see what I am saying, here will now be sin square alpha all over cos square alpha divide sin square alpha plus cos square alpha all over cos square alpha equals to sin square alpha. True or false? But note that sin square alpha plus cos square alpha is supposed to be what? 1. Note, true or false? Yeah. So note that this will give us sin square alpha plus cos square alpha is equals to 1. So it means the left answer will now be sin square alpha all over cos square alpha. Let's convert it. Okay, let's leave it like this for the sake of manias. Amen. Cos square alpha is equals to sine square alpha. So this one will now come up. So our sine square alpha all over cos square alpha, if we convert it to multiplication, times cos square alpha all over what? 1. This is equals to sine square alpha. This and this will go. So you can now see that we'll be left with what? Sine square alpha is equals to sine square alpha. And this satisfies the proof. This satisfies the proof. Yeah, any question? Look at the board. This satisfies the proof. True or false? It's true. So, do you have any question? We want to move further to consider more examples. More examples. Let's consider more examples. Okay. Cleaning. Let's consider more examples. Another example, proof that sine raised to the power 4 x, f beta minus cos raised to the power 4 beta all over sine square beta minus cos square beta is equals to 1. This is another lovely question that we want to look at. Another lovely question we want to look at. So if you can see what I am saying, it is not difficult. Yeah. It is not difficult. Let's write proof. Amen. Here is sine raised to the power 4 beta minus cos raised to the power 4 beta sine square beta minus cos square beta is equals to 1. It's simple as ABC. Let me just open your eyes. If we have a square, okay, a raised to the power 4, we can rewrite this in this form: a raised to the power 2 all in bracket raised to the power 4, power 2, two of us. Right now we apply power law, we still get back this. So if you agree with me, excuse me, So here will now be sine square beta, all in bracket square, then minus cos square beta, all in bracket square, all over sine square beta, hope you are seeing the board, minus cos square beta, which is equals to what? 1. Amen? Okay? So now, as it is, this is a difference of what? 2 squared. Right? This implies that this is the same thing as sine square beta plus cos square beta, then minus sine square beta, minus cos square beta equals to 1 all over sine square beta minus cos square beta. You agree with me? So you don't need a prophet to tell you. It means this and this will cancel. Oh, sorry, here there should be no sign here. Yeah. By the time you multiply this out, you get back this. So this and this will cancel. You can now see that we have sine square beta plus cos square beta equals to 1. You can now see that this is 1 already. So therefore, this is equals to 1. And this satisfies the proof. This satisfies the proof. This satisfies the proof. Do you have any question before we move further to solve more questions? More questions. Any question? Okay, let's move further to solve more questions. Let's move further to solve more questions. Show that, an example, show that tan square theta plus 1 plus tan theta sec theta equals to, I think I'll clean this up, equals to 1 plus sin theta all over, let me clean here, all over cos square theta. Amen. It's simple as ABC. Okay, so let's consider this example. Right, let's consider this example. Okay, let's note that our tan theta is always equals to sine theta all over what? Cos theta. True or false? So here will be sine theta all over cos theta. If you agree with me, say amen. Amen. Okay, plus 1 plus the same thing. Instead of tan theta, we write sine theta all over cos theta times sec theta. Let me clean this other part. Okay. Okay, so this is equals to the right hand side 1 plus sine theta all over cos square theta. Amen. Let us also note that what is tan theta. Note that sec theta is equals to 1 all over cos theta, cos inverse. True or false? True or false? Look at the boards. True or false? It's true, right? Look at the board. Okay? It is true, right? So instead of sec theta, we replace it with 1 over cos theta. So here we are going to have, you can see what I am saying here will be sine square theta all over cos square theta plus 1 plus sine theta all over what? Cos theta times 1 all over cos theta, which is equals to the right answer 1 plus sine theta all over cos square theta. Amen. Okay. So if this one multiply this, we are going to have sine square theta all over cos square theta plus 1. Then plus sine theta all over cos theta times cos theta. We have cos square theta equals to 1 plus sine square theta, sine theta all over cos square theta. Amen. So at this point, what we need to do here is we take LCM, true or false. Note that there is an invisible one here. So if we take LCM of this and this is what? Cos theta, cos square theta, true or false. So this divide this, we are going to have sine square theta plus this to this cos square theta, then plus this to this sine theta. This is equals to 1 plus sine theta all over cos square theta. Amen. Then already, let's come back here where here note that amen. Note that, do you agree with me? Note that our sine square theta plus cos square theta is always 1. So sine square theta plus cos square theta will be 1. So here will be 1 plus sine theta all over, can you see what I am saying? Equals to 1 plus sine theta all over cos square theta. And this satisfies the proof. This satisfies the proof. Amen. Yeah. This is how you are going to prove this type of question. This is how you are going to prove this type of question. Any question? Do you have any question that you want to ask? No question. Okay. Gentlemen and ladies, thank you for your time. I really appreciate your patience. May God bless you. Please like, comment, and share this video. Your time is up. I want to welcome new students. I want to learn calculus this morning. Okay, you are all welcome. Calculus students, you are welcome. How was your night? Hope it was okay. Yeah, you are welcome to this morning class. We'll be looking at calculus anytime soon. Okay? Yeah. Calculus students, you are welcome. And it is 211. This is calculus. We'll be looking at integration. Integration. We'll be looking at integration this morning. I'm not saying electrical on the electrical student, agric, and which other students. I'm not saying you guys. In last week we use integration using substitution. Okay, that is what we'll consider. Yes, last week we consider integration, two of us, and we were made to understand what integration is all about. We solved linear problems. We also integrate quadratic functions, polynomial functions, two of us. Yeah. So let me just take it once again before we move further to consider integration using substitution. In our last class, I said integration is I want to define. Can you see the board? Can you see the board? Can you see the board, please? Somebody should talk to me. Danzuma Shepherd. Can you see the board? Danzuma Shepherd, can you see the board now? Those guys from electrical, I'm just saying only one or two people. Okay, you can see the board now, right? Peculiar Agric, can you see the board? Jaws Macadas, so the network is bad. Oh, I think it should be from where you are. The network should be from where you are. Yeah, I am. The network is okay. Somebody should tell me, can you see the board? You can see the board, right? So let's continue. Let's continue. Okay. Yeah, let's proceed. So now we want to consider some functions. Amen. Some functions. Okay. Assuming you are asked to evaluate when you come across functions of this form, evaluate integral cos open bracket 3x amen, 3x plus 7, 3x plus 7 dx. Yeah, look at the board very well. Look at the board. When you come across questions of this form, you don't need a prophet to tell you. You are going to use what is called substitution. Is that clear? Yeah. You use what is called substitution. So we write solution. We write by saying using substitution. Is that clear? Okay. So it means for us to integrate this function very well, we are going to say let something, any alphabet, either let P be equals to what? 3x plus 7. True or false? So it means what we need to do here is we are going to what? Integrate this. So look at it. Here we have integral cos P. True or false? But what we need to do here is we have to differentiate this function with respect to x. So our dp all over dx is going to give us 3. So now what we need to do, we have to make dx the subject of the formula. So dp will now be equals to 3 dx. If we divide through by 3, we are going to have our dx is going to be dp all over what? 3. True or false? So inside the integral, we are going to have since integral cos open bracket 3x plus 7 dx, right? So this will now be equals to, you said let P be equals to this, so here will now be integral cos P. Then what is your dx? Dx is dp all over what? 3. Then we can factor out 1 over 3 outside the integral. So here will be cos P dp. So if when we integrate cos P dp, we are going to have sin P plus the constant. But mind you, we have 1 all over. So 1 all over 3 sin P plus any constant, either K or G or A. But mind you, you said let P be equals to this. So the final answer will now be 1 all over 3 sine, open bracket, 3x plus 7 plus k. This is our final answer. Any question, please? Do you have any question? Ask. Any question? Do you have any question? Please ask. Do you have any other question? Please ask your question. Ask your question. Look at the board and ask your question. Any question? No question, sir. We can't see clearly. I think the network should be from where you are. Somebody is asking me to take it all over again. Okay, yeah. I said when you come across functions of this form, we are going to use what is called substitution. So now they said integrate cos, open bracket, 3x plus 7 dx. So how can you integrate this function? What you need to do, you have to approach this function by using what? Substitution. That is why you now said let p, or it can be any alphabet, is that clear? Be equals to what is inside this bracket, which is 3x plus 7, right? Then, as it is, this is a function, true or false. So you have to differentiate this function because you are applying substitution. It means you have to replace this dx with what you have said, either the p, yeah. Is that clear? Then you have to replace this 3x plus 7 with what? P. So if you differentiate this function, you are going to have the p all over dx equals to 3, true or false. Since we want to replace dx, so we have to make the x the subject of the formula by cross multiplying. The p, the x will multiply 3. So you can now see that the p is equal to 3 dx. Then to make dx the subject of the formula, what are you going to do? Is it not to divide through by 3? That is why you see that dx is equal to the p all over 3. Then we now say that this is the function, the original function, true or false. But you said let p be equal to this. So cos, instead of 3x plus 7, we write cos p. But you now said the x equals to the p all over the 3. So instead of the x, we substitute this with the p all over the 3. But this is, as I was saying, this, when you have something of this form, do you know that this is the same thing as 1 all over 3 the p, true or false? Yeah. So this 1 all over 3 is a constant. We can factor it out of the integral, outside the integral. So that is why you are saying 1 all over 3 integral cos p the what? The p. So when you integrate cos p, what are you supposed to have? You are supposed to have sine, true or false? Sine p, but note that 1 all over 3 is outside. So 1 all over 3 sine p plus what? The constant. But remember, you said let p be equal to this. So instead of p, sine p, we recall sine p is equal to 3x plus what? 7. Look at it, plus the constant. Do you agree with me? Do you agree with me? Oh, Lutman, I'm from Nigeria. Where are you from? Where are you watching me from? Lutman. Ruthman, where are you watching me from? I'm from Nigeria. Okay, so let us proceed. Let's proceed to solve more examples. Do you agree with me? Let's look at it together. Let's look at more problems. Okay. Yeah, evaluate integral 2x minus 5 close bracket raised to power 7. Yes, it's simple as ABC. Let's look at this together. Let's look at it together. We are still going to use substitution. So whenever you come across functions of this form, you need to use substitution. Is that clear? So let's write solution. We write by saying applying substitution method. Substitution method, right? Okay. Amen. So what we need to do, we use any alphabet to say let's either which of the alphabet do you want us to use? We say P or U. Let U be equals to what is inside this function minus this. So it implies that our integral instead of this is U, true or false, but we are going to substitute for this dx, true or false. So what are we going to do? We differentiate this function. Our du all over dx is equals to 2. So this divide, cross multiply, make dx the subject of the formula. Du is equals to 2 dx. So if you make this one the subject of the formula, we are going to have what? Dx is going to be what? Du all over 2. So this implies that integral, open bracket, 2x minus 5 raised to the power of 7 dx is equals to integral. What is our bracket? Is u, but the bracket carries raised to the power 7. What is our dx? Is du all over 2. Then this is equals to factor out 1 all over 4 is a constant integral u raised to the power 7 du. So when you integrate this, we are going to have 1 all over 2 u raised to the power of 7 plus 1 all over 7 plus 1, right? Plus any constant. So this is equals to, let's add it up, 1 all over 2 dots u raised to the power of 8 all over 8 plus a constant. But note that we can use this one to multiply to give us 16, right? So note that our u is equals to what? So here we are going to have 2x minus 5 raised to the power of 8 all over 2 times 8, 16 plus a constant. This is how you are going to solve this one. Any question? Please ask your question. Ask your question. Any question, please? Benjamin Mark. Okay, he said I should take it all over again. Yeah, it's not difficult. Look at it. This is the function, right? So when you come across functions like this, just like go back to your chain rule, function of a function. Your chain rule, this chain rule now, true or false. You use what? Substitution, true or false. So go back to your chain rule. That is what we are doing here. There's nothing new here. So now, we'll now say let any alphabet be equal to what is inside this bracket. What is inside this bracket? Is it not 2x minus 5? Look at it. True or false? So as it is, we have to differentiate it with respect to what? X. Because we want to substitute in for dx. So if you differentiate this function, we are going to have du all over dx equals to what? 2. But note that there is an invisible one because we want to cross multiply. If we cross multiply, 1 times du is du. Then dx times 2. 2 dx. True or false? So now make this. If now you have dx equals to du. If you want to make dx the subject of the formula, is it not to divide 2 by 2? This is what you are going to do. True or false? This and this. So the left hand side will be dx equals to du all over what? Yeah. So now we now come back to the function. This is it. True or false? Equals to. Instead of this function, we write what? U. But this function, this bracket carries what? 7. So your u will be raised to power 7. What is dx? Well, dx is du all over 2. Look at it. Do you understand? Are you following? So now, this is, I mentioned it to you that as it is, dx equals to, this is the same as 1 all over 2 du. True or false? It's true, right? So, as you can see now, we factor this 1 all over 2 out. It will be left inside the integral. We are going to have u raised to power 7 du. So integrate this function. If you integrate this function, this is what you are going to have. Mind you, this is times, or if you want to leave it in bracket form, no problem. So now, if you integrate this function, you are going to have 7 plus what? 1, according to the formula of integration. All over 7 plus 1 plus any constant. But u raised to power 7 plus 1. 7 plus 1 is what? Is it not 8? So 1 all over 2, we want to leave this one inside bracket. No problem. So 1 all over 2, u raised to power 8 all over 8 plus a constant. But we can use this 2 to multiply this to give us what? 16. But note that your u is this. So instead of u, we are writing back this 2x minus 5, all in bracket, u is raised to power 8. Raised to power 8 all over what? 16 plus what? A constant. Any other question? Do you agree with me? So we can proceed, right? Can we proceed? Okay, so let's proceed further to consider more examples. Okay, let me clean this. There's another example here. Integrate, evaluate 3x, open bracket, 4x squared plus 3 raised to the power of 5 dx. Amen. It is simple as ABC. It's not difficult. So what are we going to do? Let's write solution. We use substitution by applying substitution method. So that is when we can evaluate this function. So what are we going to do? Let's just consider what is inside this bracket. We can let any alphabet. Is that clear? So we now say let P be equals to 4x raised to the power of 2 plus 3. Do you agree with me? Okay. You agree with me, right? So if we differentiate this with respect to x, our dp all over dx is going to be what? 8x, right? Okay. So what we need to do, look at the integral. I want to show you something. Look at the integral. Look at the integral. I just want to show you something. The integral is, okay, we have removed this. Let's just say within ourselves, we have removed this. Okay, let us make it in this form. We factor out 3. So the integral will now be what? X dx. Right? So it means we want to substitute a for x dx. That is what we want to do. So now here, look at it. Look at it. Look at it. So what at this point, what are we going to do? We cross multiply. If we cross multiply, we have 1 times the p is the p equals to dx times 8x dx. So can you see now? We want to substitute in for x dx. Is that clear? So for that reason, we make x dx the solid of the formula. X dx will now be the solid of the formula. We divide through by what? 8. So if we divide through by 8, the p all over what? This is what we are going to have. True of us. But mind you, there is a constant here, 3. So here, we can now write that our integral 3x, open bracket, 4x squared plus 3 raised to the power of 5 dx is equals to integral. Amen. Integral. What is our this bracket? What is the bracket? Look at the board very well. What is the bracket there? What is the bracket? The bracket there is 4x squared plus 3. True of us. But you said let p be equal to this. So here we are going to have p. Then we have what? 3, right? Already. So here will be 3p times what is our x dx? Is dp all over 8. So here will be dp all over what? 8. Amen. So as we can see now, here will now be, it means 3 all over 8 is constant. We factor it out. 3 all over 8. Open bracket, integral, amen, integral p, but this carries what? This bracket carries what? Raised to power 5. So we should not forget the power, the p. So let us integrate this. If we integrate this, we are going to have 3 all over 8, open bracket, integrate it, we will have what? p raised to the power of 5 plus 1 all over 5 plus 1 close bracket plus d. Amen. So here we are going to have 3 all over 8 p raised to the power 6 all over 6 plus d. Then this is, what is our p? This is the same thing as 3 all over 8. What is 3 times 6? Oh yeah, somebody should tell us the answer. 3 times 6 is what? Or alternatively, if you don't want it that way, 3 to each side 1, 3 to 6, 2, right? So it means here will be 1. Then what is our p? Our p is 4x squared plus 3 all in bracket raised to the power of, raised to the power of 6 all over what? 2 plus d. Then the final answer now be, use this to multiply. So here will be 4x raised to the power of 2 plus 3 close brackets raised to the power 6 all over what? 16 plus this is the final answer. Any question so far? Any question? Any question so far? No question? There is no question. We'll proceed. If there is no question, let me clean the board, then we'll proceed to consider more example. Oh, I said you can use any alphabet, Amayo, not necessarily K, the constant. It can be B, it can be K, it can be P, it can be C, it can be any, as long as the constant is a constant, not necessarily K. Is that clear? Yes. Not necessarily K. Please take notes. Okay, let's move further to consider more example. Let's move further to consider more examples. Here we have find integral 4 all over 5x minus 3 dx. It's simple as ABC. I think I got it right. Yeah. It's the same substitution you will use. You write by applying substitution or using substitution. So what you need to do, you now say, let's use another alphabet. M equals to what is inside there, minus 3. So we have to differentiate this function. So it means the M all over the X. We should learn how to use other variables. Is that clear? So we're going to give us 5. Then if we cross multiply, we'll have the M equals to 5 dx. Make dx the subject of the formula. If you agree with me, we are going to have the M all over what? 5, right? Do you agree with me? Okay. So if you agree with me, so this implies that our integral 4 all over 5x minus 3 dx will now be equals to integral 4 all over m, 4 all over m times, what is our dx? Dx is dm all over what? 5. So this implies that this is the same thing as integral. If you multiply this, we are going to have 4 dm all over 5n, true or false? So 4 all over 5 is a constant. We can factor it out. Integral dm all over m. But mind you, if we have dm all over m, this is the same thing as 1 all over m dn, true or false? Because I will refer you back to here is 4 all over 5 integral. This is the same as 1 all over m times dn, true or false? So if you integrate 1 all over m, what are you supposed to have? In, true or false? So here we have 4 all over 5 in m plus any constant. I told you it could be what? L, capital letter L, plus any constant. But note that your m is what? 5x minus what? So therefore, our integral 4 all over 5x minus 3 dx is equals to 4 all over 5 in m is what? Open bracket 5x minus 3 plus the constant L. It could be any alphabet. I mentioned it. So this is the final answer. Do you have any question? So that we'll move further to integration using partial fraction. Any question? Any question? No question? So let's move further to consider integration using partial fraction. Integration using partial fraction. Okay, let's proceed. There's no question. Okay. So we want to consider integration using partial fraction. And this will help you in your HND, what we call advanced calculus. Okay. Integration using partial fraction. Okay. So let us fix idea with example. Find example. Find integral dx all over x squared minus 4 is simple as ABC. This is integral. Is that clear? So partial fraction. So how can we use partial fraction? Mind you, integral dx all over x squared minus 4. Mind you, when you have x squared minus 4, know that this is a difference of what? 2 squared, right? This is the same as x minus 2 times x plus 2. Take note. So we can rewrite this in this form. This is dx all over x minus 2 times 2. So now we can now use a partial fraction. So here we can now say 1 all over x minus 2 times x plus 2 then equals to a all over x minus 2 plus b all over x plus 2. Yeah. This is we are using partial fraction to what? Integrate this function. So you have to listen very carefully because you will see this in your exam. You have to listen very carefully and take notes. So as you can see now, let us consider the right answer. Take LCM, right? Then the left answer will now be all 1 all over x minus 2 open bracket x plus 2 then equals to the LCM of this and this is the same thing as x minus 2 open bracket x plus 2. True or false? This divide this, we are going to have a open bracket x plus 2. And what we have here plus this divide this, we left with b open bracket x minus 2. True or false? So far so good. If we use this one to multiply this, of course multiply, you can now see that this and this will cancel. That is, this is what we are going to have, x minus 2 open bracket x plus 2 all over x minus 2 times x plus 2. Mind you, there is 1. So if you use this one to multiply this, it's the same thing. Then the right answer will now be a open bracket x plus 2 plus b open bracket x minus 2. True or false? So can you see now? This and this will cancel. The left answer will be 1 equals to a open bracket x plus 2 plus b open bracket x minus 2. True or false? Okay. So if you agree with me, how can we obtain a? If we want to obtain a or b, look at this bracket. How can we eliminate a or b? So the easiest way to eliminate, if we want to obtain a, putting x equals to 2. So if we substitute x equals to 2 here, b will be 0. True or false? We have 1 equals to a. Anywhere you see x, you write 2 plus 2 plus b 2 minus 2. True or false? Here will be 0. Look at the board very well. Amen? Amen?